Hi Joanna, so I'll begin the presentation today with a problem statement. Right. So the use of ordinary patient beds, as you can see in the right hand side, they are typically fixed in height and they lack adjustable features, which creates multiple challenges within the hospital setting. So the impact of this limitation is that it compromises the ability to position patients optimally for various medical procedures and also treatments. Patients may also face difficulties in getting in and out of bed due to inadequate height adjustments. So all these challenges necessitate the adoption of height leverage or adjustable patient beds as a superior alternative. The advantages of this bed is that it offers a range of height and positioning options, which allows healthcare providers easier access to the patient, facilitating tasks such as administering medications, changing dressings, or providing personal care. So, on top of making the movements of patients in and out of bed convenient, it is also much easier for healthcare providers to move patients from their bed to a wheelchair or stretcher. Right, so the aim of this case study is that we want to demonstrate the application of fluid mechanics in environmental engineering using the height leverage patient bed through a hydraulic system based on Pascal's law. However, we only have access to the electrical patient bed as shown in the picture here because the actual ones which uses hydraulic system, they are only available in the patient ward. But overall, the function in terms of height adjustments is still the same, and that's what we're going to look at in this case study.
Okay, I'm going to continue with the fluid mechanic knowledge. Basically, fluid mechanic can be divided into two. The first one is the fluid static, and another one is the fluid dynamic. And I will focus on the fluid static only. One of the fundamental concepts in fluid static is the pressure, defined as the force exerted on a wall or submerged item per unit area. And in order to control the behavior of the fluid, this fundamental is quite crucial in this study. And another fundamental concept in fluid mechanics is the Pascal law, which states that the pressure applied into an enclosed fluid will be transmitted equally regardless of the shape or size of the container. It means that we can lift the heavy object with the small amount of force applied with this Pascal law. As you can see, there's a lot of application of Pascal law in the current industry as well as the healthcare industry, which is the use of hydraulic pump in the patient bed. That's all from me. I pass the floor to the next presenter.
Hello and hi, I'm Fahmi, and I will explain the calculations to solve the problems. Two problems need to be solved are, first to find the force in Newton to hold the weight of the patient, and second to find force when patient had been lifted to the certain height. Two situations which are A, the rest position, which is no height limitation is implemented, and B is taking medications is when the height is implemented. So there are 6 assumptions. First is hydraulic jack is used in this mechanism. Second, hydraulic oil is used and the oil is incompressible. The system is at rest during the analysis, which is in the hydrostatic conditions. Hydraulic oil's specific gravity Sg equal to 0.87, and the radius of pistons 1 and the pistons 2 are 0.5 cm and 11.2 cm respectively, and the patient's mass is 45 kg. And first and foremost, we need to find the area of piston 1, area of piston 2, and also the weight of the patient. When we had done that, we had know when H equal to 0, patients in the rest position, no head elevation is applied, the pressure at the bottom of each piston must be same. Thus, we're using the Pascal laws equation. P1 equal to F1 over A1 equal to P2 equal to F2 over A2. From this equation, we just plug in the result, we just plug in the parameters, and we get 0.879 Newton. So, at the beginning, when H equal to 0, the required force is F1 equal to 0.879 Newton. So, we have solved the first problem.
Hi everyone, I'm Sufata Frazana. I'll be explaining for the calculation situation B. In this case, we can see that the bed has been raised up to certain height for the medication purpose. On the left side, we can see that the picture when the height is 0 cm, the lower part of the bed will be close to each other, while on the right side, we can see when the height is 60 cm, the part of the bed will be raised up to the certain point which is 60 centimeter. So for the calculation, we can use this equation, which is the P1 equal to P2 plus rho GH, and we have to assume the hydraulic oil inside the bed has the density of 870 kg per meter cube. So by solving the equation and put the unit into the meter unit, we can see that the force that we required to get the bed at the 60 centimeter is 12.8134 Newton. So basically comparing the two results, it takes more force to keep the bed elevated as it is because the elevation difference generates higher pressure. So that's why our leg need to produce more force to get it at the 60 centimeter.
Hi, my name is Hazik. Now on to the discussion. The calculations that were done previously demonstrate the use of Pascal's law and the hydrostatic pressure in the hydraulic jack to lift heavy loads. The hydraulic jack inside of adjustable height patient beds allow for the patient bed height to be adjusted without the patient having to get off. Now these calculations show how the load of the patient, the height of the bed, The pressures in the system and the fluid density affect the performance of the hydraulic jack. Now, engineers need to take into consideration to prevent fluid leakage and reduce maintenance requirements by choosing the correct materials and dimensions of the systems and which kind of fluid to choose. Because of this, newer beds also have an electronic control for finer movements and adjustments for the bed height to suit different needs of the patients and also the caregivers or the medical professionals. That's all for me.
Hi, my name is Kobe and allow me to show you the working principle of the height leverage patient bed used in UMMC. From the clip we showed previously, the patient's bed used in UMC are rather more advanced and has an electrically controlled height features. Lastly, to summarize our case study, height leverage patient beds provide numerous height and positioning options for personalized patient care. Fluid mechanics, specifically Pascal law-based hydraulic systems, are essential to accomplishing the adjustable and functionality of this bed. For efficient medical procedures such as medication administration, it is essential to determine the required lifting force. This knowledge enables medical professionals to maximize patient safety and comfort during treatment. That's all from our group 10. Thank you so much and have a nice day.